Welcome to Excel in Simple Terms, Designing a Game, Part 4. Today we're focusing on improving the appearance of the game map and the map logic. Before we start, in our previous section in Part 3, we created we made some changes on the worksheet selection. That's where you select the cell and it returns the values of that cell, which had an error in it. So looking at there was also an error on the map terrain play style. So the error was that I typed in the word column instead of COL. So when you look at the code, it should actually read should just read right grid, map terrain, comma row, comma col, comma terrain type. So let's have a look at that section of it. So that is on base cell. This is what it should look like. So this was supposed to say col and not column. So that was the one issue. Then on the second issue, that was on the main map. So that command was totally wrong. I put in the active row and the active column, and I should have just put in the button clicked and the value, because we're looking it up from the inner sheet. So you can see that here when I jump to it. Quickly see. Okay, and then also on the play style button clicked, active row, active column, it should have said active col, not active column. So those two errors caused that if you click on your map, everything else ran fine, but if you clicked on your map, it would bomb out, it would give you an error. So just by doing these fixes, that should get your map and everything running smoothly now. So we are going to start now with the map and enhancing the map. To do this, we are going to have to make a change to one of the modules. Now, I considered this module, and that is the module for reading the grid and writing the grid. This works perfectly. If you want to read the exact grid that you are referring to, in other words, you want to change column row 1, column 1, and you only want to access that cell and do a change to it. However, for the read and write grid, we actually want to be also able to compare the cells around it. So like if we generate the map, we want to see what's above it, what's next to it, what's below it, what's at an angle to it, what's on the right of it. So for that, I'm going to modify these two functions a little bit. I'm going to basically add at the end of this function, I'm going to add one option, and that's adjacent position. I'm going to make it an optional position, so if you do not enter the position, it's going to return the actual cell that you're referring to. I'm going to use the directionals for this. So in other words, I'm going to say read grid, database, row, column, and then I'm going to say north, south, east, southeast, west, northwest, to be able to refer to a cell that's next to it. It's going to help us to just create one function for the read of the grid and one function for the write of the grid, and not have to create another function to look at the cells that's around it. So to do that, we are going to grab, I've already prepared the code, so I'm going to paste it and then we're going to walk through it. So as you can see, the first part of the read grid is the same. It's the database, the row, the column, and then what is new is the optional state, optional variable, or it's a string, adjacent position as string. That's going to receive either north, south, east, west, northeast, southwest, southeast, or southwest. If it receives nothing, it's going to do no adjustment to it, so then it will refer to the cell that is existing, or that's been selected. The reason why I wanted to do it like this is with an optional statement is I don't want to have to go and change the other instances of where we used readGrid in our existing code. So because it's optional, it doesn't matter if the last variable is not there, then it's going to just refer to itself. If it has a value, then it will do the following. So for north, for instance, north being above the existing cell, it's going to -1 on the row, and that's it. So south, east, and west is all the same. It's basically just reducing or adding 1 to the row or to the column. When it comes to northeast, it reduces 1 on the row and adds 1 on the column, because obviously northeast sits to your right hand side, so the row is for northeast will be slightly upwards, being a lesser row, and on the column side it will be to your right, so it's going to increase the column. So that's basically the basis of what it's doing here. Then at the bottom, we're assuming that this is a round world. So we are assuming that if the row is less than 1, then it's going to jump to the other side of the map, and it's going to take the value of row 101 as the cell next to it. You're going to see when we get to things like being able to do weather, it's just going to create a better flow if we have a total of 9 cells that we can use. In other words, 8 cells around that's adjacent to the cell that we have selected. So we're doing the exact same thing with the right function. So if you look at the right grid, I've done the exact same thing. I've added one extra function to it. It's doing the exact same steps. It's just writing to the cell instead of reading from the cell at the end. So let's test these things. I've already created 2 little test scenarios here. So let's test a read. Now you can see I have gone and modified 101 to say soil, and I'm going to make this one grass, just so that we can see that if we get returned water, we're not going to know whether it's actually doing what it needs to do. So let's have a look. So X should return grass, because that is what is in cell 1, 1. So let's see if it's doing that. So it's stepping through. It's not finding any direction because it's referring to itself. It's checking whether there's anything is less than 1 or greater than 101, and there won't be because it is referring to a cell that's on the grid. The same with column, it won't find one, and then it is reading it. And what it is returning, X is grass. So that's done the right thing. Now I've done an XN for X north, and we're going to see if that is going to return the cell that we've got here at the bottom, which is soil. That's what we wanted to return. So we're going to read the grid. It is finding north, and it's going to take the row and deduct 1 from the row, which is correct, because we want to see what is north of that cell. And as it steps through, it's going to realize, but 1 minus 1 gives you is going to give you a 0. So it is going to be less than 1, and therefore it becomes 101, which means it's going to pick up this row. And the column, it finds no changes, nothing else to do. It reads the grid, and what it is returning is soil, so it's doing it correctly. Now we're going to do the same with testing whether it can write. So in my map lookup, I've added some other values. I think I did that already in part 2, or between part 2 and part 1, which I mentioned in part 2. So I've added quite a few other pieces on here, other tiles. I've added one for houses, which we want to be able to build a house or place a grid with a house on. or a dam or whatever. I don't think I've got dam on here, but I do have water and mountains and those kind of things. So I'm going to just go to the map grid, the map terrain, and I want to go and modify. So we're still going to stick to cell 1,1. I want to modify 1,1 to sand, and whatever's east of it, which in this case is water, I want to also modify to sand. And we're going to see if that is now going to have the desired effect. So we're stepping into sand, and it is complaining because this is a sub and I've ended it as a function. So we're going to just change that to a sub. Okay, so it's jumping to right grid. Let me just see if I didn't, yeah, so that's right. It is looking at itself, so it won't find a directional for it. It won't be able to increase or decrease the row based on the excess or the criteria below 1, because it is referring to itself. And it should now write in this, it should write our new value to the worksheet, which has done. You can see the sand is in cell A1. And now we're going to see if we can manipulate B1 the same way. We also want sand in that. So we're going to step through. It's finding east, so it's increasing the column with 1. It's not going to find any other directional, and it's not going to find anything here because we're not running off the grid. We're not looking at west. And it is returning sand to that. So let's test west to just make sure that in the other direction it is also running fine. It should. So I'm going to step into this, but I'm just going to move it past the first one because we've already done that. And we're going to run through it. It's found west. It's going to deduct 1 off the column, which means it's going to be off the grid. So now it is finding the row hasn't, it's not on a grid, on a row level that is going off the grid, it's on a column level. So it should now find that, and there you go, it's found that it is less than 1, so it's going to make it 101, and it's going to write and end this up. And let's see if it put sand into that, and it did. So we're happy with this function, that it is working, that the changes that we've made is actually having the desired result. Now we have enough tools to actually start with our map. Okay, so we're going to start with generating the map. Now I want to jump to a section here where we created the message, and I just want to create another function, public function reset message, and this is just to clear out that message that we have displaying at the top at the end of each section of the map that's running. So it's going to be the display, we're going to just say reset message, and that's going to do message nothing in message 1 and message nothing in message 2. Now, because we're generating a totally brand new map, we're going to clear out our terrain generate, and I'm going to be creating little sections like map terrain ocean, map terrain sand, etc. That's going to get called from map terrain generate. So this I'm all going to clear out, and I'm just going to put make ocean in there. Now at last we are at our map and getting our map drawn. So initially what I did is I got my program to run through all the tiles, convert them into ocean, then go and in a specific area draw a block of sand. And I thought the best way would be to then go and kind of carve out in the sand an area where so it's not so square, to carve out little pieces of that of the sand where it just replaces it with ocean. What I got is a map that looks kind of like this. So not really what I wanted. It's still very square, and it doesn't give you the feel of actual real landmass. So then I started, I had a look around. Obviously this is very new to me. I've never done a game in Excel. So this is totally a new exercise for me. And there's some things like that I've been deciding to play with then, to try and get this map into a little bit of a better shape. So I had a look around and I saw noise or specifically Perlin noise, and I thought, well, this is probably the way to do it. So I had to look around then and try to find some VBA code for the Perlin noise formula, and I could find nothing. There's probably something out there, but the only stuff I could get in VBA was stuff where it's compiled already, so you can't see the code. Which I think is the problem, the biggest problem in VBA in any way. It's not with Python. You've got people collaborating and sharing their code. With VBA, people hold their code very, very close to them, and I understand that because it takes a lot of time to program something. But at the same time, you're making it more difficult for other programmers to enter the market when they have no idea how to code something, and people do help, but vaguely. And that is the problem that I found with trying to find something where I can use Perlin noise to generate my code with. I struggled with formulas. I'm obviously not a mathematician, and what I could find was formulas in mathematical notation which I honestly don't understand. So I then had thought, well, after reading all this material, I got a general idea of what Perlin noise does. Although I must be honest, even with the map that I did generate after this, I still found the implementation quite difficult, purely because I've never used it before, and I haven't. There's not enough information available on how to convert that mathematical formula into actual VBA code for a person like me who's just a layman and trying to figure out his way. So I kind of developed my own little Perlin noise method, just using the basic concept of it. I can't say I got it totally right, but it did create a bit of an improvement on my maps. So I'm going to just close this sheet. So what I got when I look at my new map is a map that actually looks a little bit more like landmass. So with my first try, what I did is basically step through every single tile, starting in the top left-hand corner, working to the end of the row. Basically just embedding one for loop within another for loop, and that clearly didn't work too well. So what I did with this instead is I decided to first convert everything to ocean like I did before. Now, what I don't like about this map is I like the little bit of coastline with the beach around the edges, and that I have not succeeded in doing yet. But at least it looks like a landmass. So what I then did with a subsequent method is I decided to make use of a slightly different method to try and get a Perlin noise variant. So in my code, I created, you can see I've created quite a few extra sheets in the meantime, which I intend on using, which is not quite there yet. But essentially I went to go and create a map elevation, thinking that I could just generate the map straight from an elevation map, but basically by doing my ocean, picking a point anywhere on the map, a random point, and then starting to spiral out. To just show you, I'm going to show you on this. So essentially what I did is I said, if this is the point that it's picking, I'm going to just highlight it so you can see which point I'm referring to quite clearly. Then first go upwards and kind of work your way clockwise around the edge, which would cover the square around it here. That covers this square. Then once you get to this point, you step one up and you do the same thing for the next square, going around the edges, and you basically land up covering this square. And I basically then said, well, do that. If you do that for the center point, the next row, the row after that, the row after that, and the row after that, in other words, 5 layers, you basically get 80 blocks. So what I then said, got the program to do is say, you pick a point, then you decide how many of those blocks you're going to generate. So you might say, let's say this one is point, the yellow block is block 1, and you get to block 2, which is the one above it, block 3, block 4, block 5, block 6, block 7, block 8, block 9, block 10, and let's say you've generated 12, so 11 and 12, and it's going to end there, and that is what it's going to generate. Then it's going to do the same thing multiple times. So basically, I used a dice, and I said, well, I throw a dice as to how many times you will be generating those individual blocks. And obviously, they're not all exact square blocks. They're kind of half blocks and portion of blocks, because it depends on how many sub blocks, if you want to call it that, it will be generating. So that then I assigned a elevation to each of them, saying wherever you start, that's going to be the highest elevation, and then when you get to the next row, you're going to do a lower elevation, again with a dice throw, and then again and again up to your 5 blocks. And then you're going to pick your next block and start with a high elevation again and do a spiral around. Kind of like a volcano world. You know, if you assume that there was ocean and then there's a volcano and it slowly forms the land around it, and that is what I had in mind. What transpired was that my elevations didn't quite work out because they're overlapping. The elevation went kind of up and down, and the elevation also didn't step down to the levels that I anticipated. Because I kind of thought that within 5 blocks I can relatively quickly get it to step down to basically sea level, and it didn't quite work out like that. And that's the thing about designing something like this that you've never done before, is you get surprises. So instead, you know, initially I thought, well, then it's going to be easy. I can kind of use the same method as what the Perlin method is in shading those different areas as I go. You know, basically using the elevation to shade them. And as I say, it didn't quite work out as that. So then I decided instead, well, I'm going to create the landmass, and I'm going to mark it all as sand, just like I did in my previous version. I'm going to mark everything as sand, and then I'm going to place my rivers. I'm going to basically say a river also selects a point somewhere, but the proviso is that it must be on the sand. It then surrounds it with mountains, like you can see I did here. That little section is all mountainous, so it's everywhere around the river. It basically places some mountains, and then your river starts stepping towards the ocean. So it's going to pick a direction with a dice throw, and it's going to step 1 block in that direction. Then it's going to throw a dice again to decide, is it going to continue the same direction, and if it is, but it can never return on itself. So I've basically only given it allowance to either to, if it's moving north, it can only move east or west from there, but it can never go back on itself, because otherwise you're going to have, you might run through 500 iterations and it might be stepping forward and backwards and never reaching the ocean. And then I made use of the chance of 10 formula to say there's a very small chance that that for certain directions that it will be moving in. So let's go and have a look at the code that I did so far, so to give you an idea of what I mean. And then anyway, once your river reached the ocean and it's generated a couple of rivers, I think I set it to 10 if I remember right. And once it's done that, then it goes and fills in all the other land spaces with little blocks, also depending on the change of 10 chance to kind of determine there's a bigger chance of X being, or for instance, grass being a tile than something else maybe. So basically in the code, you can see I created a nature general, and then I created, I'm on nature. That's something I've created for the future that I'll show you in the future. It's these are the one that says terrain. So I created terrain general, and that's my main code. You'll see in the meantime I've started putting option explicits and my dims in. Look, option explicits are not. It's not going to block your program from running. However, the benefit of option explicit means that every variable after that you have to define. And because you are defining the variables in advance, the space in memory for those variables are allocated, which means it doesn't have to happen while your program is running. So your program does run a little bit faster. I mean, in tests that I've done, you can barely see the difference. So it is not an absolute must, but something that I find a little bit irritating is when I type dim and I do a capital T and it changes it to a lowercase t, and then nothing that you can do in your code is going to change it to the case that you want. But once you've set a dim, if you define it there, it will definitely stay a capital if it's a capital, or a lowercase if it's a lowercase, and that I just find a lot easier to code with. So that's what I've done, and I've started doing that in all my other modules. I know in the beginning I didn't show you option explicit, and that is actually quite important to just allocate your memory up front. So my first step was to basically make a map, and then I've got my message box that shows. I have started tweaking a little bit on the message box, because you remember we created a toolbox at the top, and that toolbox was kind of in the way because it was overlapping because of the message boxes that takes up the first two rows. It kind of takes up the space over your tiles, so you can't really see all your tiles. And I want that memory, that little toolbox to sit just over the Excel menus and not below that. So what I did instead is my toolbox name, I changed here to selector. I mean, it doesn't really matter what you call it. And I took the message boxes out. Instead, I put the message boxes in a little pop-up box that just comes, that's going to display. Just remember, when you create your pop-up box, just remember to change the modality of it. You'll see here, if we look at modal, let's quickly just see here, it says show modal, and I said false, because otherwise your program will pause until that box is closed. And we don't want that. We want the box to appear over your map, do what it needs to do while your program is still running in the background. Look, Visual Basic doesn't can't use multiple processes at the same time, so it is not really happening at the same time. It's kind of jumping between them, and it is one of the downsides. There's ways of doing it in Visual Basic, but it's not really happening in Visual Basic, because that means you have to write something in the background in C, or in another language that can kind of deal with that, and then make use of it via your Visual Basic code. And that is beyond the scope of what we're going to do here. So I'm trying to build whatever we're going to build in Visual Basic, so a person who wants to learn a little bit about Visual Basic can actually do it without having to go and do things in other programming languages outside of Visual Basic. So to just demonstrate how the map then finally runs is, so I'm going to just run this module. Just want to quickly switch out of this and switch back to map. So when I say make map, it's going to say creating random map. Now the messages, you'll see that I did quite a lot of changes to this code, so it's not going to show you every block that it's generating. Showing every block does make it take a lot longer, because it's having to jump back to your message box, generate that piece of code, and then jump back to your code and continue there. So you can see every time that we run this map, it's going to generate something totally different, and it is really just by kind of spiraling out, creating little points all over on the map and spiraling out to generate the points. There's some strange anomalies on the map that I still want to do a bit of work on, but in the meantime I'm going to just show you what I've done. So I basically start with a start land row and column, and the end land row and end column. The reason why I do that is because I don't want my land to be the same size every time, so it's kind of a dice throw as to where exactly it's going to start its position. And I said the start position will be somewhere between 3 and 10, and the column will start in kind of the same positions, and then it will end somewhere between 91 and 98. And you're going to see, so because I want an edge of ocean around it, so I don't want it to go up to 101 and start at 1. And also because of the spiral method that I use, basically what I did is if it's going to spiral, and it's going to spiral outside of the point where it's selected, then it's not going to generate that specific point. It's going to rather throw the dice again and select another point. But because of the parameters of where I've set it here, it's never going to get to it's never going to run off the map, and it's not going to rethrow the dice. And then the first step is basically I stepped from 1 to 100 in the rows and in the columns, and then just changed everything to ocean. So you'll see that this is the general, and it's calling do ocean RC, and do ocean RC is the row and the column. As you've noticed, in my main module I use R and C, and then in my sub columns, in my sub modules, I use another variable, because otherwise if you modify your R and C in your sub module, it will also be modified here. So you're kind of going to contaminate the one module with data from the other module that is being changed out from under it. So when you jump to ocean, you can see it is very straightforward. So in the meantime, I've created those extra grids, and basically what I did is I said the terrain for it is going to be ocean, its elevation is going to be 0. I didn't do anything below ocean level. I don't think I'm going to take the game to that level where you're going to do anything under the ocean, so I don't think it's necessary. Then I started with my ideas for the weather, which is I want a groundwater and a kind of if you want to call it that, air water. It's the evaporated water in the air. So the groundwater, as the temperature changes, more water will evaporate, which will add to my map grid air water. The air water, the wind will then will determine what direction that water is moving in, and when it accumulates in a specific tile, to an extent it's going to rain, and then add again to the groundwater. So it's kind of creating a little a little cycle, a weather cycle. Then I created a map tile that is for ownership. So it's exactly the same as your normal map terrain tile. It's just going to have all the ownerships are going to be set to 0 because it belongs to no one. Once you're in the game and we start buying land, then it will change it to your land or another player's land. Then the map price, I just kind of basically for each type of tile, I set a price. This we'll probably work on a little bit more at a later stage. And then I did a tile for map resources. And I haven't quite decided if I'm going to keep this as one resource or multiple resources. I may make it, I'm not going to make it too complicated, so I may make it just a couple of resources, maybe things like wood and stone and gold, you know, the normal stuff, or I might do something totally different. But basically I'll have a grid that records how much of a specific resource is on a specific tile. And that all I write right here when I do the tile ocean. So in the ocean, my resource is probably going to be something like fish. And that is basically what this does. So it when it says do ocean, this is kind of a waste what I did here with the do ocean, make tile ocean, and then jumping to make tile ocean. So I'll probably eventually get rid of the do of this module and just rename this one do ocean, because it's going to kind of do the same thing. I had another idea behind it where I wanted to do a little bit more calculation in do ocean, but I think one module is fine for each of these. And I kind of did the same thing for forest and grass and hills and mountains. Basically, you can see if I go to hill, it's kind of the same code. Here I just didn't do the do hill. I just created a make hill. And then grass, the same. I just kind of did that. You can see the variables are slightly different. My terrain is grass, obviously. The elevations is somewhere between 6 and 10. So that's what these guys are basically doing. Now, my sand that I generated. So you saw in the main code. Not nature. I keep jumping to nature. Terrain. I basically generate my ocean and then I make my land. So to make a land, I've basically said I'm going to run this little looper, but I'm going to run it somewhere between 100 and 500 times to actually generate the full map. Because remember, as I said, it spirals and it create from points. So it's going to create somewhere between 100 and 500 points and spiral out from that based on the criteria of how many blocks that I'm going to place. So you can see it does a dice for the row, a dice for the column, and a dice for the block size. So it's going to be somewhere between 1 and 80 that I want that block to spiral. And then it goes and does this do elevation RC, which is the row and the column, and the drop land block size. And then when you go to sand, you're going to see that. So the first thing I did, now here you can see the do elevation and the make tile sands make a little bit more sense, because there's some logic happening here, and there's quite a lot of logic. Unfortunately, as I said, I'm not a mathematician, so I've had to break it down into all the individual components that will actually make up what I'm trying to achieve. There's probably a much better formula to do it with, and I invite you to experiment. And if you come up with something great, then please let me know. I always like to try and streamline my code a little bit better, but this is what I came up with. So I kind of said, okay, so when you're in block 1, which is self, the self block, then you are. I just created a new variable block I, because I don't want to modify the I and the J here, because then I'm going to modify wherever I use that I and J. So I just created a new block I and a block J, and that is where I'm going to say, okay, well, I want you to first look at yourself, which is I and J with nothing added, and then get a random elevation, and the elevation we get from the bottom here. And I just said anything from that, any block that's from 0 to 8 will get a high elevation. Any block from 9 to 24, which is basically the next circle around, will get 200 to 500 elevation. Any one in the column after that will get a 25 to a 48 elevation. Between block 25 and 48 will get 100 to 200 elevation, and then my last block, the outer block, will get somewhere between just above ocean level and 100. And so you can see that I had to repeat this for every single block, because I had to go and add, in my first block I had to go and -1 from I to get to the row above it, and the J will obviously be the same because it's still in the same column, and I had to do that for every single one of those 80 blocks. And this is where I think my formula can be streamlined quite a lot. It's just I have not figured out a way to do it yet. So each one of them I do the elevation, and then I go and make tile sand, which is running up to the top and generating the map terrain, the elevation number, the groundwater, which I just set at 10 for sand. This I will eventually build a formula of some sort to use the temperature and the wind and all those kind of things to move to decide on groundwater and air water and how it's going to move. The temperature I just set at a specific temperature for the type of terrain, and obviously the ownership 0, and the price for sand will be 25, and then my map resource I just set at 5. It's low resource on sand in my mind, and essentially this is how this runs. And as you can see, it does run different every time that I run the map. You can see that the landmass changes, and it looks a little bit more like a landmass, not like a little square that I had in my previous one. So with these, with the code, I do realize that just from videos, it's quite difficult to follow the code always and to see the changes that's being made. So I'm going to set up my website, bringmesome.co.za, to host the code, and I will let you know the moment I have done that. It will probably be by the time that I've done my next video. And then I will take these code snippets and put it there, show it by section that it's in on my my actual program. And for you to be able to follow along, I'll put the images there that I'm using, etc. And I think it's going to be a lot easier for you to follow along with it, as if you actually have the code to do this with. Thank you very much. I appreciate that you've been watching my videos. If you like, if you like my videos, please like and subscribe. And I look forward to the next session of our video, where we're going to start tweaking the game a little bit further and start to get it to be a little bit more of a playable game.